Fibonacci numbers. Obviously, you've heard of this. 1 plus 1 is 2, 2 plus 2 is 2 plus 1 is 3, and so on. But the digits get extremely enormous as you keep going. We're talking tens of thousands of digits long. We're looking for the first one where the last 9 digits use every number 1 through 9 exactly once and separately. The first 9 digits do the same thing too. Both ends with the same huge number with all 9 digits. Kimi K3, Fable, GPT 5.6 Sol, Grok 4.5, no hints. And this one actually needs some real math to even be possible, not even just a clever shortcut. Okay, so here's what makes this genuinely hard. The Fibonacci numbers we're eventually looking for has around 70,000 digits. So if you just try to compute that number directly in full, every single time you check it, you'd be doing that hundreds of thousands of times as you search. And these things get bigger every single step. So there are two separate problems buried in here. First, checking the last 9 digits. Turns out you don't need the whole number for that. If you just track everything using remainders, keep dividing by a billion and keeping what's left over, the last 9 digits behave exactly the same forever, no matter how large the real number actually gets. The first 9 digits though, that's a different problem. You can't get those from a remainder. You actually need to know how big the number is. There is a trick for that though. Fibonacci numbers grow at an extremely predictable rate tied to the golden ratio. So you can actually count how many digits a given Fibonacci number has and what those leading digits are using logarithms without ever writing out the full number at all. So the whole problem really splits into two separate puzzles. How do you track the end of the number forever, and how do you know the beginning without ever computing the middle? GPT solves both halves the most expensive way. For the ending, instead of carrying a small remainder forward step by step, it recalculates it fresh every single index and then checks. Same correct math, remainders the whole way through. It just restarts the process over and over instead of building on what it already knows. And for the beginning, it computes the actual Fibonacci number, the full one, tens of thousands of digits long, using a fast method for building numbers big, efficiently. Both pieces are done properly, it's just doing an extremely expensive version of it. So Fable's the only one that speeds up both halves at once. Tail carried forward the whole way, never recalculated from scratch using the remainders, and then for the front, a straight logarithm estimate with no giant number ever being built. Same correct method as everyone else underneath, it's not paying for either expensive part. Grok speeds up one half of this. For the ending, the same story as GPT, calculating fresh each time instead of carrying it forward using the remainder. But the beginning, instead of ever building the giant number, it uses that logarithm trick, straight to an estimate of the leading digits with no massive number ever being created. So half the savings, same slow way of tracking the tail, but a genuinely fast way of handling the front. Kimi does the opposite trade. For the ending, it carries the remainder forward the whole time, one step building on the last, but never starting over. For the beginning, it goes directly back to building the real number, the full-sized one. Read off the digits directly. So it saves time on the half that Grok didn't, but spends time on the half that Grok saved. Different half optimized, but the same overall idea. So all four models land on the same Fibonacci index, 329,468, but GPT pays for both expensive parts. Grok saves time on the front half with the logarithm trick, but still recalculates the remainder every single time. Kimi does the reverse, keeping the tail remainder trick, but forgets the logarithm trick. And Fable does both at once, efficient the entire way through. So the winner this time is Fable again, and it's really not about undoing your own progress. Once you know how to track something efficiently, carry it forward and don't start it over, especially in math. Grok and Kimi landed right behind it, tied in spirit, each one just solving half the problem faster than the other one. And GPT is not wrong anywhere, it's just paying full price in terms of efficiency on both sides of a problem that don't really need to be this expensive. The real answer is Fibonacci number is 329,468, a number with tens of thousands of digits, and somehow both ends of it use 1 through 9 exactly once. Same four models next time, but a different problem as always.